Following on from the previous video, we were in the process of showing that this green area is always 3 times the size of this red area. So we were in the process of working out this green area. So the green area is given by the integral of the cycloid from 0 to t. So that's this left green. Later on we will add it to this right green. So for the time being, this area here, the left green, this area here is given by the integral from 0, from 0 to t, and this was the stage that we got to in the previous video. So now it's just a matter of integrating this. So factor out all the r's, so that will then give us this, and then now just multiply this out. So if you multiply this out, it will then give you this, and then to integrate cos squared, we would use this. We would put this into cos squared. That will then give us this bit here. So now it's easy to integrate. So hang on. So now to integrate this, let's merge these two together. That will then give us 3 over 2. But when you come to integrate it, it will be 3u over 2. That will then give us this. This is easy to integrate. That will then give us this thing here, and then this thing here, to integrate it, it will then give us this from 0 to t, from 0 to t. So now we can put t into here. That will then give us this. Put t into here, and then put t into here. That will then give us this. So now double angle here. Whenever you see a double angle, we can use this. So so this thing here. Hang on, let me think. Hang on, let me think. So this thing here, well, this whole thing here will then become this thing here because we used this. So that will then take us to here. So the left green, remember the left green is this area here. It's given by this whole thing here. So now we need to consider the triangle here. So the area, the right green, which is this area here, is given by the hang on, let me think. It's going to be the base here is given by this whole thing here, and the height is given by this thing here. This is the height. So that would be this. Let's try and look at the base. So remember, we've seen this before. The distance from here to the center here in terms of the x direction will be given by RT. We've seen this before. This distance here is given by RT, and then your x location. So the x location. So this distance here is given by this. So that's given by this. This whole length here is given by RT. So the base of this triangle is given by RT minus this length here, minus this length here. So this is our base here. This is our base. Hang on. This is our base here, and the height is given by this. So the right green is given by the whole thing here. Well, if you tidy it up, it will then give you this thing here. So we've got the left and we've got the right. So the whole green is given by what we worked out earlier, plus, so this is our left green, and this is our right green. So the whole green is given by left green plus right green. So if you tidy this whole thing up, it will then give you this, and then continue tidying up. That will then give us this. So now tidy this up. That will then give us this. So the whole green is given by this thing here. Now let's look at the red. So hang on. Let's look at the red. The red. Hang on. So the red would be this whole thing here. So this whole thing here. Take away this triangle here. So if I were to give you this, let's say I give you a circle of radius capital R. Let's just imagine we're working let's just imagine we're working in, hang on. Let's just imagine we're working in degrees. If I were to give you this, it would be pi capital R squared, and then cut up into 360 degrees, and then times by t. So this whole thing here is given by pi capital R squared, cut up, now because we're working radians, it would be 2 pi and then times the angle, which would be t. So this whole thing here is given by this, but then we've got to take away the triangle. We've got to take away this triangle here. We've got to take away this triangle. Well, the area of this triangle here is given by this. So this whole thing here is given by this. Take away the triangle. Well, the triangle is given by this because, hang on, if you were to draw, let's say, a straight line here, this will be your right angle here, and the angle here, this angle here, is t over 2. Is t over 2. So this thing here will be cos, will be given by this thing here, and then the height will be given by this. So the whole area here is given by this thing here. So hang on. So the red area is given by this whole thing here. So now let me think. Tidy this up. That will then give us this. So whenever you have so here you've got well, we can make use of this to tidy up this whole thing here. So bear in mind that that this angle here, well, bear in mind that this is always twice this angle here. Okay, so if you have half t here, then you're going to have one whole t over here. Well, think about it. It's just badly explained by me. This thing here, well, half angle here. If just bear in mind, if you have half of this thing here, then this thing here will be one whole thing, because this angle here will be twice this angle and this angle. So bear that in mind. Okay, so if you tidy up this whole thing here, it will give you this whole thing here. Just badly explained. Think about it. From here, that will then take us to here. So now tidy up this whole thing. That will then give us this thing here. So now the red area is given by this. Earlier, the green area was given by this, and you can see that the green area is always 3 times the size of the red area. So I hope you can see that. Okay.